All right. So last week, I know we did this. We talked about mass and weight and volume and density. And we talked about force. Okay? We talked about all this. So, what we're going to do today is we're going to try to relate two of those concepts. Okay? So, on this says 1,000 G. What do you think the G is? Grams. So, this is 1,000 grams. What is that a measurement of?
Mass.
Okay, it's a measurement of mass. Now, we talked a lot about mass last week, and I feel like you guys settled on this idea that mass is a measurement of the amount of particles in an object. Okay? So this one says 500 G. So if you could visualize 500 individual particles, this would have 1,000 individual particles. Is that cool? You guys feel okay about that? So we're going to assume that whatever it says on the object is the correct mass for that object. But we're only going to work in kilograms. Is that cool? All right. So I have these two objects. Here, hold these. Okay. Got it? All right. So I want to know. Hold on, I got to do a thing. Okay. Which one weighs more?
This one.
That one weighs more?
Oh, well, it feels heavier, yeah.
Feels heavier. Is that good? Yeah. So I'm with Sophia on this. When she says the one that feels heavier weighs more, I think that is a great way to think about it. Okay? That is a great way to think about it.
Don't post that.
How can we, okay, is there a way that we can measure the weight of an object?
On a scale.
Okay? I think a scale is the right way to do this. So I have a scale. Okay? I have a scale. Isn't the scale adorable?
Yeah, that's right.
Okay? Where have you seen something that looks like this before?
You put your fruit in.
What's that?
Yeah, the best.
So
That's what you do when you go to the airport or lift it up.
Yeah.
one of the ways to shop is to say, like, I want to buy some bananas, but I only want to spend $3 on bananas. And I look at the price says $1.99 per pound. So I know I can get 1.5 pounds, and they have a scale that looks like this, and I put the amount of bananas I want. Right? So instead of buying the number of bananas I want, I'm going to spend this much on bananas. That's one way to shop.
Yeah.
So if I put this on here, is this going to tell me the weight of the object?
Yeah.
Yep.
How much does this object weigh?
10. What are the units on that?
10 something, right? If you look closely on here, it says 10 newtons. Newtons is the measurement of force that we are going to use. Okay? Newtons, of course, named after
Big Newtons.
the delicious fruit cookie. That is correct.
I feel like that is.
All right, so
They're disgusting.
I've never seen
I have no clue what that is either.
Yeah. I just know what they are. If you
all right, so here we go. Here's our object over here. What are the forces? What are the things that are pulling and pushing on our object?
the weight,
Tell me one.
scale.
Gravity.
Okay?
The scale.
So remember, to draw this, okay, you draw the dot. This is the object right here. And then we're going to use arrows to represent the things that are pulling and pushing it.
Yeah.
Tell me one physical object that's pulling or pushing
The
on.
scale.
Okay, the scale doing what?
It's pushing up.
Okay, in this case, there's actually no normal force.
The scale is,
That one. Yeah. perpendicular to the object.
Because of
So
the.
like,
What is that?
Okay? So that is the force of the scale on the object. Is there something else that might be pulling or pushing?
gravity,
So we need a physical object.
so the earth,
Good. What's the earth doing?
pulling it towards the earth.
Pulling it down.
Oh, yeah.
Okay.
Like earth.
And when I'm holding it, what can you infer about these two forces?
They're equal.
Why do you think they're equal?
Because the object's not moving.
So because the object is not going anywhere, can you infer that the forces are equal?
Yeah.
I think that's okay. So this, last week, you guys decided that this, the force of the earth on the object, this was our definition of the weight. Okay? That's our definition of the weight. It's the force of the earth on the object. Is that cool? But you can't measure that directly, right? But by using a scale and understanding that these two things might or have to be equal if it's not going anywhere, this is what the scale reads. Is that cool? So that's what you guys are going to do today. You're going to use this idea that by holding it stationary, this force is equal to this force, and we're going to let the computer determine this force for us. Does that sound good?
Yeah.
Easy. Fun, fast, and easy. Cool?
Yep.
All right, so we're not going to use this because this is a little bit imprecise. Okay? We're not going to use this because this is a little bit imprecise. We're going to let the computer do it for us. Okay? So you are going to select various objects with different masses. They're good because they like hang like monkeys in a barrel. So if you did this one, it would be 1,000, 1 kilogram, 0.5 kilograms, and if you hang them together, it would be 1.5 kilogram object. See how that works? All right, so on the lab side, you guys are going to plot the mass in kilograms. You're going to measure the weight in newtons. Okay?
In Newton?
Sound good? What do you think the research question is on this one?
What's the relationship between weight and mass?
Yeah, what's the relationship between weight and mass, or mass and weight? Thank you, Ronan, I heard you. Okay? Make your columns. Everything that's on the lab rubric, you're going to do. Is that cool?
We do it in whiteboard?
So I'm going to send you to the lab. You're going to need a computer out of the box. All right, you're going to need to make sure that the force sensor is hooked into the interface and that the interface is hooked into the computer. Start the Logger Pro program. When everybody is set with the Logger Pro program up, we need to calibrate the sensors. Then you guys can take the data. Sound good? Let me give you some new lab groups.
I don't like that.
I like that one. We had it one.
Yeah, I like this.
Wait, but then what do we?
Nice.
It'll be like this, like the one that we were in, it'll be like this, we're next to each other. Dude.
I don't even remember last time.
I don't even remember.
And then your intro.
That's my last.
Bro,
Who are we missing?
Okay.
Are you watching?
Yeah.
No, it doesn't work like that.
your mom doesn't care about me. I'm in the board talking so much.
No.
Why are you thinking about saying that?
Mr. Adam, please.
Yeah, so funny.
Like, I'm fine with it. Like, no, like,
That's not good.
Well, I mean,
When I was watching, I never got that. I was like, ugh.
Same problem.
Bro, I thought you did.
Ready?
No, I mean,
All right.
like, I didn't get it. Like,
Listening closely, please. Listening closely for your lab group. Ready?
Yeah.
1, I got Caitlin, Cole, Annabelle, and Madeline. 2, Sahib, Danny, and George. Maybe I should.
No, you go.
I should
No, just wait.
3, Grace, Lexi, and Mars. 4, Brendan, Nathan, and Toshi. 5, Lauren, Lizzie, and Sophia. 6, Ronan, Charlie, Ren, and Jacob. Okay? Stations are 1, 2, 3, 4, 5, 6. Jacob, will you? George isn't here. Will you join those 2 boys?
I would love to.
Looking for you guys? Two?
Oh, yeah.